Okay, so when we left off, we had just solved this problem. That is, at least we'd found the direction using Scratchpad. And at this point, I want to show you a slightly different approach. Before we start, let's remember some things here about general algebra. First, we have a first quadrant there, second quadrant there, our third quadrant there, and over here, this is our fourth quadrant. So, if we keep that in mind, when we consider things like functions like tangent, atangent, arcsine, arccosine, they have some very limited ranges. So, for example, if you're dealing with tangent, this is what we're going to talk about right now. If you're dealing with tangent, basically, tangent will give you an angle that will correspond to something in the first or fourth quadrants. If, on the other hand, you deal with an interesting function called atan2, which I will demonstrate shortly, it's defined over all four quadrants. So, let's think about something. If I have a vector in this direction, say f1, it has a positive x component and a positive y component. If I had a vector over in quadrant 2, it would have a positive y component but a negative x component. A vector in quadrant 3 has a negative x and y component, and a vector in quadrant 4 has a positive x component but a negative y component. So, making use of that, let's sort of redefine this problem. We're going to do it with Newton's second law. We're going to sum the forces, and the sum of the forces should be equal to 0. Let's capture some of this, because we're going to recycle part of it. Let's grab that part. So that part of it all will be exactly the same. Let's move that on down. Scroll down. Oops. Now let's scroll down. And if the sum of the forces are going to equal 0, well, that means we're going to have the F3 term on the left-hand side. Also, we're going to use angle theta 4 instead. So we'll grab some blue just so we can see the difference. So this will be plus F3 cosine theta 4 equals 0. This is our new equation 1. And our new equation 2 will add this plus F3 sine theta 4. Now we're going to solve this for F3, and I want you to... There's going to be some hair splitting going on here, but it's an important hair splitting. So if we solve the first equation for F3, that's going to look like this. Negative, parentheses, cosine theta 1, F1 cosine theta 1 plus F2 cosine theta 2. And all that is going to be over cosine theta 4. Now, considering that F3 is a magnitude and therefore can only be positive, the fact that I have a negative sign in the numerator, I know all of this is already going to be positive based on my inputs. The fact that I have a negative sign in the numerator means that the denominator has to be negative. And for the denominator to be negative with cosine, that means I've got to be in either the second or third quadrants. Okay, so let's now have our alternate expression for F3 using equation 2. So this is going to be F1 sine theta 1 plus F2 sine theta 2 over sine theta 4. Again, since the numerator is going to be negative, the denominator must also be negative if F3 is going to be a positive number. Now, I want you to understand that this expression and this expression up here are qualitatively the same, and here's where the hair splitting comes in. what we've got to do, effectively, is enter these expressions in to our tan2 function. So let's go ahead and rearrange. We'll get a tangent much in the same way as we do over here. So we'll have a sine theta 4 over cosine theta 4. I'm just going to equal all this other stuff, but I'm going to keep these signs here. I'll have a negative f1 cosine theta 1 plus f2 cosine theta 2. That's my numerator. I'm holding on to that sign. I'm not going to let it cancel. Minus f1. Yep, hold on, I did it backwards. Curses. Well, that's where we have stuff like this, so we can move things around. Get rid of them. Okay. And now let's move that back up, save a little bit of writing. Okay, here we go. So that's my denominator, and my numerator is going to be very similar. F1 sine theta 1 plus F2 sine theta 2. Right, so you have all that. Again, notice these negative signs. This is, of course, equal to tan theta 4. Now, the tan2 function, so if I want to get the arctangent, inverse tangent, a tan2 is a function where you input the y, sine and all, and you input the x. The idea is that based on the sine of the y and the sine of the x, it chooses which of these quadrants your angle is in. So it's defined over the full 360 degrees. So let's go ahead and apply that. So here's my scratch pad. I've actually moved a little bit ahead, so let me go back and show you. So before we were up to here. Now in this case, what I'm doing is, let's fix this up a little bit. So this is my y, and let's put a negative sign here. And this is my x, and I'll put a negative sign here. So again, from before, we defined S1 as the sine, S2 is a sine of theta 2, and so on. Let's take these negative signs out. And let's make sure that we are on the right window so that we have proper scope. Alright. And now clear. Alright. And let's run it. That's a really interesting result. What that's saying is if we just do it the old way, theta 3, with arctan, we end up having an angle of 39.89 degrees and change. If we do it with tan2, and we respect the quadrant, and we've set it up using Newton's laws, we get this particular result. We have an angle with respect to the positive x-axis of negative 140 degrees. And that's really interesting, because it means that this is a much more robust function, and it's really a better way to get a general solution. So you've got a couple of ways to do it. You can do it using pure geometry if you have a pretty good sense of what to expect, or you can do it using mathematics without necessarily understanding which way things are going to point, and let everything come out in math. So let me just come back to the screen here. So, and actually, here's one thing where you might be able to get me on if you're nitpicky. Really, if I look at this very carefully, the theta 4 I've solved for is really this. That's my real theta 4, not the one in the light green. And you might say, well, how's that possible? Well, it turns out that those two are equivalent angles as measured from the x-axis. One is less than 180 degrees, the other is greater than 180 degrees. And if we want to be real specific about tan2, it's defined from negative pi to positive pi, or negative 180 to positive 180 degrees. Right, so anyhow, I hope that answers some of the questions about how you can set this up, why both this approach and this approach will work. Good luck.